Hey, so welcome. We're gonna do some data transformations, another term, data manipulations in R. And there's some packages that you need to install if I haven't installed it already. So the first one is this NYC um, flights data. We're going to use it as a point of reference, which is fine. And then also, I believe we already installed remotes, but also install this, James IJW23 Stack Cal Poly. Once you install those, you can run these two lines. I'll run all three lines, but because I already know you have dplyr, arbitrary NYC, and Stack Cal Poly package. When you're installing Stack Cal Poly package, you're gonna have to press 3 for none. There's going to be an option. It may come up, and if within the console, you should press 3 for none. Okay. All right. So I'm gonna go ahead and run this. It's already installed these packages. I'm just double check I'm being recorded. Okay. So it ran. It's good. So if you notice, I'm in visual today because I'm going to show you some animations, so some GIFs. So you can run this in animation. It's going to work. It's a URL online. So this is hopefully this woos you in liking this particular mechanism of programming in R. So for this particular lesson, we're going to learn what this particular code does. Okay, so we're doing some joining. And so when it comes to joining, we have to join by, in this particular situation, carrier. Okay, this is the interaction that you'll be doing. Okay, and tail number. So at the end of the video, you should know what left join and inner join are actually doing. And so when I run this, okay, that makes sense. That makes sense. Why it's taking so long? I shouldn't have done that. Okay, at least it's running. It's running because it's taking so long because it's a big data set. I'll let it pause. I'm gonna pause the video. Don't run that line. I definitely had to terminate my R because it's so much data. Just for funsies, we can just view. I had to restart R. That's funny. View flights. And then when I do that, it's going to mean you see if you look at it, it has 336,000 rows. That's a lot of rows. And it's doing something. You don't know what it's doing, but it's doing some joins. You're going to learn what those joins are today. With that being said, let's look at left join. What is left join really doing? So what it's doing is you have two data frames. Right now you have data frame X and you have data frame Y. And what it's doing, it's actually combining these or joining these two data frames only on the matching numbers or matching IDs. So you can see, and then the resulting data frame, as these two data frames are coming together, 4 goes away because there's no match, but 1 and 2 are added with new rows, new columns, Y1 and Y2 for row 1 and row 2, where 3 does not because there was no data frame, there's no row in the right data frame that corresponds to number 3. Hopefully that makes sense. The image gives it more justice than my explanation. Okay, and so that's how a left join works. So you're joining two data frames to have a resulting data frame based on a common variable. So let's actually look at this in the most basic form. So there's a data frame within stat Cal Poly package called, let's look at the team one, the basic team. And the reason why I'm so happy we're not doing the NYC flights because that data frame is so complicated or so big. Let's look at this very simple one. Okay, so let's look at it here. Basic team data frame. Okay, so here you see ID 33, 122, and 530, group age, and gender. Okay, and then if I look at basic, do it again, basic team, another data frame, basic team F1. well, that's not the best one to look at. Let's look at F2. This one is a good one to look at. So if I do a left join, right, you'll see that the common IDs is 122. There's no 333 here, but there's a 530. There's a 530. So if I were to do a left join, where so if I were to do a left join, let's say that this is left, okay, and then this is the one on the right, are the right, F2, right? If I do it that way, I should result in a data frame that has only 3 rows. Okay, so let's do that so you can believe me. Left join, basic info, and I'm gonna do something that's not good. No, I'm not gonna ever do it again. Basic team F2. Okay, I'm gonna do something that's not good. So what I'm gonna do is I'm actually going to bind our joins are. Join, I'm going to say this is df, but the bad thing I'm going to do is I'm going to leave out the by. So if you notice in these, I did a by is equal to, obviously, the column name. The image, the actual GIF does not show that you have to do that, but you should do that. And it's going to work, but what you're going to see is that it's going to tell you what it's doing it by, and there's a huge amount of opportunities to make mistakes when you do that. So you see it's telling me that it's joining by ID. I'd rather tell it that I'm joining by ID. So again, look at what it has. It has 3 rows because it's matching on what we have in terms of variable information. We have did I do it right? I did adults. My apologies. It should be teen. I'm like, why is that the case? My apologies. And let me fix my mistake. By is equal to ID. And make sure that's in the parentheses. Okay, boom. Join. Okay, now that makes sense. Okay, so it had 122, it had 530, but it didn't have 333. Let me show you that again. It had 122 in the right one, it had 530, but it didn't have 333. That's why we have NA for number of tournaments and level. Whereas the original, the left data frame had 333, 122, 530. Now if I flip it, I get a total different data frame. Okay, it's going to now have 8 rows. Okay, if I just flip the order, so this is why you got to pay attention. So flip the order. Okay, boom. So it's going to have 8 rows, and only 2 of them are going to have the information from the right. So we're going to join data frame. Okay, now you can see it's different. And only 2 of them are going to have information from the right. As you can see, 333 is not there because it's not on the right hand side. Hopefully the animation in the demonstration makes sense to you. And just based off of time, I'm actually going to ignore. You can do this on your own. There's 2 methods. I'm not going to run the code because I think it's going to take too long. But this should be carrier number. Let me just confirm that. I know that. I don't know why I'm second guessing myself. It should be carrier. That's what it should be. And there's 2 ways of doing this. Okay. One method is just by using the traditional, left join. But another way of doing this, easier way to write this, I'm just going to copy and paste it just so I can write faster. An easy way of writing this is to have flights on the outside of this function and utilize what function? The pipe function. Oh, sorry, the pipe operator. So there's a pipe operator, and this is another way of writing the same exact thing. Okay? So these 2 data frames would be equivalent. Okay? Okay, so we're doing left join here. However, the data frame is a little bit bigger, and so I think it's easier to understand with a smaller data frame. So at least you see it being done twice. Okay, you can read what the concept is, you can read why it's important, and so on and so forth. The right join is just the same thing. I never use the right join. Because why? It's the same thing as the left join. So why need to stress? So I just use the left join. But I'm going to go over it again. Okay, and I'm just going to show it to you. Use right join. But this time I'm going to use basic teenager teen df. Okay, and then I'm going to pipe this into a right join. And then what I'm going to do is basic teen f2 df, and then say show right join underscore df. And again, this is bad because I didn't do what? I didn't say by is equal to id. By id. Okay, so when I look at the right join df, you can see it has the same dimensions, but it's in a different order. And one reason is because of the ordering of the data frame rows. Okay, this is because of the order of the data frame rows, but these two data frames are the same. These two data frames are equivalent, because if I were just to sort by, so you can believe me, you get the same exact data frame when you sort it. Sorry. And the okay, because it has the same columns and also the same row information wise. That's what I mean by the same. I don't know if anyone was questioning that, but that would have been a good question. Same thing here. We would do carrier. This is just carrier. Okay, by carrier. Okay, and then the method 2 is by using the pipe function. All right. So again, right join and left join work very, very similarly. It's just that you are putting your main data frame, your left join, for example, your main data frame is on the left, and your whatever you have common with your left and your right, you're going to keep your left, but only match on your right, match from what you have on the right. The new concept, inner join, works a little bit differently. I think this is one of my favorite joins. The inner join, if you haven't already scrolled down, works in that it only matches on what's on both data frames. So this time it's going to drop that 3 from the left data frame and drop the 4 from the right, and whatever is matching will stay there, will be there. Okay. So the best way of looking at this is to, again, I'm gonna do what use the pipe to do this. So I'll do inner df, okay, inner join, and you still have to include the by symbol, so by argument, sorry. So if I do this, it's going to be basic teen df, right? I'll pipe this into inner join, okay, and then I'm going to do basic teen f2. And when I do this, I'm going to get a data frame that has 2 rows. Okay, I don't know the number of columns. I think it should be 9. Oh, no, it should be 6. Sorry, it should be 6. But it should be 2 rows, right? So let's look at this. You see 2 observations. Okay, and the reason for that is because those are only rows that match. So if you look at, this is why the video is a little longer, because I'm going to show you this. If you look at this, you see that ID 122 and 530 is in that data frame, okay, which then matches only with ID 22 and 530. So those, when you do an inner join, only matching IDs will show up in the resulting data frame, and that's why we only have 2 rows. Okay, so even if I were to flip the order, the columns may change in terms of the actual display, but it's still going to be the same rows. So take note of that. That's so cool. I love inner join. Inner join is one of my favorites. Okay, and so you see again, still inner join is the same thing. Okay, same number of rows. Okay. What time do I have on here? 15 minutes. All right, that's fine. I mean, we're learning. Let's learn. And so this one right here, I believe it's still carrier. I'm bypassing this particular data frame because of how big it is. I suppose I'm getting more. I think you all are learning. Let me know what a thumbs up on on the video if you're learning more with, in a comment, learning more with the simpler data frames. You can try this on your own. You see, it's going to be kind of hard to follow what's changing because these data frames are so big. I shouldn't have done that. Is it tail number? I think it's tail number for inner join. Yeah, it's tail number. Sorry about that. Alright. But again, the reason I'm not looking at this is because you can't see what's going on in 284,000 rows. It's fine. Let's just keep going. So full join. I like full join, but the utility behind full join is there. I say the biggest ones are inner join and left join. The other join, there's semi-joins and anti-joins, but this is summer. This is summer. Alright, so full join just combines everything. If you think about it, it's going to combine everything. Okay, no matter if there's a match or not. Okay, and so that's what we're seeing here. And so we can do that here. So if I do this now, I should have 9 rows. That's a count. Alright, so if I do this, I do, I'm going to say full join. And the naming convention I'm using is not the greatest. It's just that these data frames are meaningless at this point. But I'm just saying full join data frame df. Okay, full join. Okay, boom. Then I'm gonna, and then as you can imagine, order does not matter here. Order does not matter here. Team. Okay. Oh. I want to use the pipe function. Sorry. And then basic team F1, F2. Okay, and I'm still gonna do by, even if it still would work. It's convention, and it's nice for you to get your mind mentally always thinking in that manner. So this should have 9 rows, 9 observations, and still 6 variables. Exactly, because now 333 should be here. Exactly, and it would have NA for this information, and these individuals have NA because they're not in the second data frame. We're almost there, y'all. Almost there. 2 more concepts. You can read why this is important and explain what the concept is. Okay. All we gotta do is some binds. So you have bind rows and bind columns. So bind rows, these are very dangerous. I used to use them when I first was introduced to R back in the day. I'm not trying to elicit any type of fear, but you'll see why they're dangerous in one moment, now that you know what joins are. Okay, so if you're doing a bind row, let's look at the example that I'm trying to elicit here. So it's basic team data F2. That's what it is? Okay, let's just look at this, the example that I thought to use. Alright, so this one here has ID, number of tournaments, level. Okay, bind rows. Okay, but then if I do the same thing in terms of adults, basic adult F2, it has the same. It has different IDs, of course, because it's different people, number of tournaments there, levels there, but this one has number of days. So the reason why this is dangerous, this one is not as dangerous as the next one I'm going to mention, but this one is going to essentially put all the information of number of basic team info, basic info team F2 on top of basic info adult F2. But for days, it's going to have NA, okay, for the teams. Okay, that's what bind rows does. It just binds the rows of data frame. It just binds the rows of data frame. In this situation, I do not need a by statement because I'm not matching. That's the dangerous part, because I'm not matching. Okay, so bind rows, and then this is going to be basic info adults F2. So bind rows df. Okay. Again, even if you want to, there's no by argument in this, so that's fine. And as you can see, I'm gonna have NAs for the teenagers. I don't even argue some. This is just, again, this is not manipulation. This is just a manipulation. This is not for a given purpose. A purpose would, I would do this because I don't know, I can't even delineate who's who in this situation. Let me say that again slower. Even if I'm at 20 minutes, I'm going to say this again slower. This is important. This is basic data manipulation. This is for no reason. If I were to be doing this in real life, this would be horrible in that I don't know which data frame, which rows correspond to teenagers, which one corresponds to adults in this particular resulting data frame. So that is key. That's important to know when it comes to working with data. So this is just for us to learn what these concepts are. Okay, very dangerous. Okay, now let's do what I was saying. That I'm actually going to use a really, really bad thing to do. In that I'm going to bind two columns. Okay, I'm going to bind columns. As you can imagine, if I'm binding rows, I'm putting them on top of each other. If I'm binding columns, I'm putting them adjacent from one another. And look at this. Look what I can do, which is dangerous. Basic adult info, and I'm just going to pipe it into bind columns. But guess I'm just going to do it I'm just going to bind it to the teens. This is so bad. This is so not bad. Because we know for a fact these two pieces of information should not be associated with one another. Okay? The reason why it's saying new names, and you're going to see it's going to say .x, .y, is because they have the same variable names in both data frames. Bind columns. Oh, I didn't even do the .x, .y. I just did 1, 2, 3, 1. Okay, so because these two are the same, these are the same. So wherever there's duplicates, it has to append the name to have something different. And so this is their current mechanism of actually delineating the difference between the two data frames. Okay. So again, this is bad because you're not matching by any ID. Again, these are two data frames that don't belong to one another, but you know what it's actually doing. The manipulation, the transformation in and of itself is just putting two data frames together by row, whereas by column you're putting the two data by column, but by row you're putting one data frame on top of the other. That is it. It's a long video. I appreciate it, and I'll make another video tomorrow.